In question 18, we start off with this kind of nasty looking arithmetic sequence with a variable k in it. And then we have to figure out t6, a general term tn, and a value for k given that t20 is equal to negative 16. I want to make a couple of changes to this sequence just to show you that it's not really as bad as it looks. The first one is to change the k into a fraction that has the same denominator as the other two terms right after it. So if you multiply k by 3 over 3, you get 3k over 3. And then the next term is 2k over 3, and then 1k over 3, and then 0k over 3. And all of a sudden, now you look at the numerators and it's actually a pretty simple sequence. It's really just going 3, 2, 1, 0. So the next one's going to be negative 1k over 3, negative 2k over 3, etc. And we've already got t6. All right, so t6 is negative 2k over 3. Right, there's our t6. But we've still got some work to do. We'd like to know the general term, tn. Well, first thing in calculating the general term is always to calculate the common difference. And the common difference here is no more difficult to calculate than elsewhere. You just simply take one term and subtract the previous term. So let's take any term, let's say 2k over 3, and subtract the previous term, 3k over 3. I could have picked any two terms, and we should get the same common difference. That's the definition of an arithmetic sequence. And so I get a common difference of negative k over 3, and you could have just seen that from looking at the progression of the terms too. All right, the next thing we need to figure out a general term is the zeroth term. Well, the zeroth term is the one that comes before the first term. So if you look at what's going on with the numerators there, 3, 2, 1, 0, negative 1, negative 2, obviously the zeroth term is 4. All right, so 4k over 3. So that's t0. All right, so we've got everything we need for tn. Tn is simply the common difference times n, so negative k over 3, n, plus the zeroth term, 4k over 3. And you can leave it like that, or since they both have denominators of 3, you can combine it into a single fraction with a denominator of 3, and it becomes negative kn plus 4k. And you could even factor out the k if you wanted and write it, but I think that's adequate. All right, so let's take a look now at the third part of this question. If they give us a value for t20, t20 is equal to negative 16, can we figure out what k is? Well, using the general term, we can figure out what t20 is just by substituting 20 wherever we see n. So it's negative k times 20 plus 4k all over 3. But we know, we're told, that that's equal to negative 16. So we have an equation here in k, and it's a straightforward equation. It's got a fraction in it. I always recommend multiplying both sides by the denominator if you see a fraction, or the common denominator if there's more than one. So we'll multiply both sides of this by 3, and we'll be left with the numerator, negative k times 20 plus 4k is equal to negative 48. And negative k times 20 is just the same as negative 20k, plus 4k becomes negative 16k. And now we can divide both sides by negative 16 and get positive 3. And let's just check this. So tn is equal to negative k over 3 times n. Well, if k is 3, that becomes negative 3 over 3 times n plus 4 times 3 over 3. All right, so these 3's cancel out and become 1. These 3's cancel out and become 1. And what we get left with is negative n plus 4. So if t20 is equal to negative 16, the general term for that sequence is pretty simple. It's just negative n plus 4, and therefore t20 should be just negative 20 plus 4, which is negative 16. So that's our check.